In this video, I am going to demonstrate Data Studio's table feature. In Gauntlet 2, you're going to use a table feature to collect data for angles and acceleration rates for carts accelerating down an incline. And from that, you're going to create a mathematical model so you can predict accelerations if I give you any angle. So let's start here with the data table. Okay, so I click on the data table feature here. I'm going to scale this over. So the first thing you're going to want to do is collect acceleration rates for different angles and plot them, and then see what kind of best fit line and equation you can make for it. So in the x-axis here, I'm going to say, let's pretend you're going to collect data for angles in 10-degree increments, 40 degrees, 50 degrees, 60, 70, 80, and probably not 90, but I'll put that there. And let's say for each of these angles you measure an acceleration rate. I'll make it simple. I'll make it squares. 1, 4, 9, 16, 25, 36, 49, and 81. I missed one here. 64 and 81. Okay. So as I plot that data, you'll see or as I type in the data, you'll see I get a plot. Again, this is acceleration versus angle. Okay. And then I chose 10-degree increments. And the bottom line is you want to create a mathematical model or find an equation for this line. So I'm going to highlight all the data starting at the top there. Oops. Starting here and highlighting the data like this. Okay. And to me this looks like a parabolic relationship, so I'm going to say fit quadratic fit. And I get a quadratic fit here, and it looks like I get an A, B, and C coefficient. So these are coefficients of a quadratic type formula. Here I have an example of what that might look like. So here's a quadratic equation. So A is the A coefficient of the x squared term, B and C is a constant. So in mathematics class you'll see y is a function of x. In our specific example, it's going to be acceleration as a function of angle, acceleration as a function of theta. Okay, so that's what these variables mean. The mean square error tells you how well the fit is. The closer to 0 error I get, which this is pretty close, e to the minus 23rd, the better. Let's just say I, for sake of argument, thought it might be a linear fit. Well, I can do a linear fit. Okay, it's not as good a fit as a quadratic, and I can see by error, the mean squared error, I get an error of 52. So that obviously is not a good fit, so I can get rid of that. And then I can choose other fits like inverse squares, natural exponents, logarithms. Actually, logarithm doesn't even work there. Okay, so you after collecting data and determining what fit you're going to have, and for this specific example, it looks like a quadratic, although in reality the acceleration as a function of theta is probably not quadratic. You're going to take that equation and build a Google spreadsheet to test it. In the next video, I'll talk about how to build that spreadsheet so that you can predict accelerations based on angle. So, for instance, I might give you an angle of 33 degrees. You set up your experiment to be 33 degrees, and you predict, based on your model, an acceleration rate of, I'm just eyeballing it here, but you would do it precisely with the equation, maybe 12 or 13 meters per second squared, and then we test that. So that's the use of data tables and Data Studio to create mathematical models.